So the focus of today's topic is AlexNet. AlexNet is a convolutional neural network architecture, and it is designed by Mr. Alex and some of the related co-authors. Now the point is that from where to start, what is the fundamental contribution, what are the stepping stones in this particular work, and where to go and find the actual research paper that is going to offer the literal research cornerstones of this particular work. So let me introduce this particular work step by step. So hey there, my name is Rohit Kumar, and today's focus is AlexNet, and we are going to show you the ImageNet classification with the deep convolutional neural networks, where we are going to discuss the different sorts of key terms related to AlexNet. This particular work is part of advances in neural information processing systems in NIPS 2012, and paper is bit old, but still a lot of related details are going to be there, especially for the AI and machine learning enthusiasts. So let's start. Coming to the specific synopsis of the work, we are going to have some of the highlights. For example, users have used a large deep convolution neural networks to classify the 1.3 million high resolution images in the LSVRT 2010 ImageNet. ImageNet is a popular data set which is used for different sorts of image classification, segmentation, etc. purposes. So if you are interested in the field of image processing, etc., you can go for this particular data set. We have covered a particular dedicated video on ImageNet also. So if you are interested, you can go and check out the details. Coming to the other points, so authors have achieved the top 1 and top 5 error rates of 39.7 and 18.9%, which is considerably better than the previous state of the art. So it's the basic work to do. Whenever you are doing some research and you are getting some results, always compare with the current state of the art. So with respect to 2012, they have compared that time's state of the art, and they have obtained these error rates. So these are supposed to be considered a better one. And one more thing, that the non-saturating neurons and the efficient GPU implementations have been used by the authors. So let's directly jump onto the paper and let's see that how they have used and designed this particular work. Whenever we look onto a work, always also look from a close point of view that how the papers are being written, how the people are using some particular syntax, how they are maintaining the sections, etc., how they are putting the images. These all things will help you to design a particular work, especially if you are a beginner or the early career researcher. So let's just start. Here you can see that following the abstract, the basic introduction, then they jump down to the dataset part, because in the title only it is very clear that ImageNet classification they are focusing. So obviously ImageNet should be in focus, and that's why the ImageNet is a dataset of this. The basic detailing of ImageNet they have provided, and then they have jumped onto the related details. Coming to the architecture, so here they have provided the architecture in figure 2, then they discussed figure 2 here. You will find here it is the figure 2. Okay. Then they have discussed the ReLU. Then ReLU is an activation function. Then training on multiple GPUs, because the multiple GPU discussion they have involved. Then local response normalization, overlapping pooling, etc., etc. Means all these terms are related to AI. So if you are working in the field of AI or deep learning, now obviously you must have been familiar with all these things. So we are not going into the details. We are just focusing onto the key things that whenever you are jumping onto this particular work, always look and focus on the most important part of this work, that is ImageNet. Secondly, you need to focus onto the GPU implementation, because when you are having the very large data sets, then obviously normal CPU implementations are not going to help you out. So that's all from this particular video. And the point is one more thing, that as we are discussing AlexNet, so one basic thing is this, that AlexNet is a classical convolution neural network consisting of convolutions, max pooling, and dense layers. So these are some of the basic building blocks. And whenever you are having some grouped convolutions, so means they help you to fit the model across multiple GPUs. So that's the fundamental key concept behind. Additionally, coming to the importance of AlexNet, many people do ask that how you can claim that it is so important or something like that. So this is only done with the help of the wide popularity. So AlexNet is quite widely popular. And if you have any doubt, you can go to Google Scholar and check out the works which have used AlexNet as their component or the part of the work. So number of papers are available there. I'm going to just mention one or two works, and if you are interested, you can go and you can find more of the related works. So one work is the traditional and heavy drilled self-regulation in neural network models. This is the 19 work, and they have discussed the self-regulation concept in neural networks. Additionally, there is another work is self-labeling via simultaneous clustering and representation learning. So the representation learning has been the focus of this particular work. Coming to the third one, the coordinated filters for faster deep neural networks. So similar way, multiple works are available, and if you are interested, you can go on, because there are hundreds of works which have used AlexNet. So you can think of that what sort of popularity AlexNet has gained over the period of time. And when you go into the actual implementation details, you will get to know that why it has become so popular. Now coming to the some of the basic things that you can do with the help of this particular neural network. So the general classification, the image classifications, sort of object detection, then compression, network pruning, object recognition, etc. Some of the common tasks that you can do with this particular neural network. And over the period of time, the ResNet, VGG, DenseNet, and the MobiNet, mobile net, those are supposed to be a kind of competitor to AlexNet. So when you are comparing the AlexNet with the other data sets, you should also see that what sort of works the other networks are being used for a particular purpose. So similar way, AlexNet, ResNet, VGG, DenseNet, MobileNet, these are some of the common networks which are used for a variety of tasks, variety of common tasks. So if one network you are not means kind of compatible with, or you are not getting good vibes, then you can move on to the other one, and then you can try whether you are having the good hand with the other one or not. So that's all. Coming to the conclusion of this particular video, I will just want to say that whenever you are going for a particular kind of neural network, just go inside, see its actual architecture as they have shown you in the work. So in the work, they have shown you the architecture, they have shown you that how the model is learning, how the different sorts of data sets have been used, how the different sorts of error ratios have been calculated, and particularly on what basis they are considering the improvement of the proposal based on the current state of the art results. So the comparative analysis is very important, because based on your comparative analysis only, you are going to claim that your work has gained some sort of edge over the existing state of the art works. So that's all from my side for this particular video. Hope you must have liked some of the details. If you didn't like, please do criticize the video by commenting down below. I will definitely go through your comments and would like to incorporate suggested suggestions. So thank you. Wish you good luck for the future. Happy learning. Thanks.